Okay, so hopefully you guys are doing great with the amplitude graphs and then the period graphs. And now we are going to do our last two examples, 5 and 6, in which we are now going to put both transformations together, an amplitude and a period transformation. So taking a look at this one, we see that our amplitude, the absolute value of 3 is 3. And now we have a period transformation. So 2 pi divided by the b of 2 pi is going to be equal to 1. Okay, so what changes will occur to the parent function of sine x? So normally our amplitude is 1. So we see that we have the amplitude is definitely greater than 1. So we are going to have a vertical stretch. Okay, so we're going to have a vertical stretch. It's going to be the first thing that we notice. Then our period is now 1. Okay, so the period is 1. So usually we're comparing that to 2 pi, okay, because the normal period of sine is 2 pi. So 1 is definitely less than 2 pi. 2 pi, remember, pi is about 3.14. So 2 times 3.14 is about 6.28. So that's definitely less than. So we are talking about a horizontal shrink here. Okay, so we have two transformations going on. So when we go about doing this, we want to still take a look first at our period, okay, as we did in the last example, so we can figure out the beginning start of our graph, the end of our graph, and then the middle part of our graph and what's happening in between. And then from there, once we have our x tick marks, we can then figure out our y min and our y max. Okay, so instead of being at the 1 value for amplitude, we now know that it's going to vertically stretch to a 3. Okay, so if you still feel that you need to graph the original, you can do that. Okay, or you can just do it from the values that are already given to us. Okay, so we know that we have a value of 0. We know that our period is ending at 1. Okay, so that means our whole entire sine curve is getting squished into the period of 1 that is right here. Okay, so that means that we have to take half of that value, the half distance between 0 and 1, okay, because sine hits the x-axis halfway between 0 and 1. Okay, so it's pertinent that we know our sine curve. Okay, so we're going to have an x value at 0.5. Okay, now remember, we now need to get half the value between 0 and 0.5, okay, because of the symmetry of the unit circle. So we need to know what is half of 0 and 0.5. Okay, so half of 0.5 is 0.25. So that means that right here, this little x value right here is 0.25. And we know that the sine curve goes up usually to 1. Okay, but this time it has an amplitude stretch to 3. So instead of graphing it here at 1, we're going to plot a point all the way up here at 3 as the y max. Okay, so then as we go down to so now when we go to halfway between 0.5 and 1, you could either do 0.5 plus 1, which is 1.5, and then take half of that. We now know that this is 0.75, which is where we're going to then take our next value, which is then going to, instead of going to -1, we're going to bring it all the way down here to -3. So if we very carefully draw this, okay, and I know I'm not looking for artistry here, okay. Let me try that again. I apologize. Okay. So we're going to come all the way up to here. Make sure we hit as close to the points as possible, making it look like a curve and not. Okay, so we see it's very slender. Okay, it's very thin and slender here. Okay, and then we're going to try to do a couple more periods. So then we know that the next period is going to be 1 plus 1 is 2. Okay, so here's our next one. Halfway between 1 and 2 is 1.5. Okay, and then we're going to go between 1 and 1.5, which is 1.25. So that means that I now need to have another y max of 3. And then I need another y min at between 1.5 and 2, which is going to be 1.75. And here's my dot down here. And then I'm going to try to very carefully draw myself another line. Okay. And we get a very, very slender, stretched out, squished graph compared to the regular sine curve, because remember the regular sine curve is 2 pi and 3.14 is all the way out here. So if you think about it, the regular sine curve would be out here somewhere. If we were to, I'm just going to show you real quick. If it was the original sine curve, it would be about 0. Pi over 2 is about 1.57, and it's 1, so it would be about here. And then 3.14 is about here. That would be the first. I'm just going to kind of dot it so you guys could see, just so you could compare. Okay, but that would be the original graph, and then I actually don't have enough room on this function to continue on. Okay, but that would be the first hill as you go forth. Okay, so you can see that this graph is stretched out. Okay, and it is definitely period wise, it's moving much faster, and it has condensed horizontally. Okay, so now I'm going to go to example 6. Right, example number 6, and this one we are also going to graph another one with period change, amplitude change, and notice this one has a negative in front, which means that we are also going to do a amplitude change. Okay, so let's take a look what happened, or I'm sorry, not an amplitude change, we're also going to have a reflection. Okay, so let's see what actually happens. All right, so we have an amplitude. Amplitude is, now don't be mistaken because of that negative, okay? The negative does not mean that there's a negative amplitude, okay? It's the absolute value of -2, okay? So the absolute value of -2 is going to be +2, okay? So when we think about what's happening here, 2 is bigger than 1, so that's going to be a vertical stretch, okay? It's going to give us a vertical stretch. Then we're going to take a look at the period. Okay, period normally is 2 pi, so we're going to do 2 pi divided by 2 over 3, which is going to be times 3 over 2, and the 2's will cancel, leaving us with 3 pi. Okay, so 3 pi is greater than 2 pi, so that means that we're going to get a horizontal stretch. Okay, so there's going to be a lot of stretching going on for this graph. Kind of the way I felt after eating Thanksgiving dinner. All right, so then the negative here is then also going to tell us that we're going to have a flip or a reflection over the x-axis. Okay, so let's see what this does real quick. Okay, again, there's no problem in doing this in different colors to help you out. Okay, so our normal cosine graph starts here at 0, 1, pi over 2, and then it comes down here, 3 pi over 2, and then right here. Okay, so in the pink graph, here's my normal one. Okay, and then comes back down to here, and then 3 pi, so forth. Okay, so sometimes you're not always going to get like an exact amount, meaning that you're not always going to have a graph, a full period when you graph it, depending on what is given to you on the graph. Okay. So in this case, I did not give you a full amount of graphing room to do a full period. Okay, I gave you actually kind of like 2.5. Okay, so now I'm going to graph this in blue. Okay, so again, start with the period. So 3 pi. I'm going to start here at 0. Okay, so 0 is where I'm going to start, but remember I have a amplitude change. So before I graph my amplitude, okay, I know that it's going up to 2, but it has been flipped over the x-axis. Okay, so here's 2, and then flip it over. Okay, so here we are at 2. Okay, and then we're going to go to the right. We know 0 is going, oh, sorry, 2, -2. All right, now 3 pi is where it's going to end. So I'm going to put a value down here at -2. Okay, so remember with cosine, the y's have to be the same for the min and the maximum. Okay, so the next thing we're then going to do is we're going to cut this in half. So what is halfway between 0 and 3 pi? Okay, halfway between is 3 pi over 2. So pi and 2 pi, we know that the middle point is right here at 3 pi over 2. So if you want to, you could like just put it on the here, make it listed. I'm going to put it on the side here just because I don't have enough on my actual graph. So I know that this is 3 pi over 2. Okay, and the midpoint of 3 pi over 2, it doesn't cross through 0. It's actually a minimum for cosine. But remember, I had to flip this graph and I had to stretch it to 2. Okay, so normally it would go down to -2, but then I had to flip it. So I'm actually going to put it up here at +2. Okay, and then we remember that since I'm at 3 pi over 2, I now have to cut in half between 0 and 3 pi over 2 so that I could hit through 0. Okay, so how do I do that? So we're going to take 3 pi over 2, okay, and dividing it by 2 is the same thing as multiplying it by half. So this is actually going to be 3 pi over 4, okay? So if I count my blocks here, I have 1, 2, 3, 4, 5, 6. So that means I need to go to the third one. So 1, 2, 3 right here. Okay, that second one right here is going to be 3 pi over 4, and we're going to plot that that's a point that goes through it. Okay, so you can either draw an arrow to that or whatever you have to so that you know that this point right here, this x value is 3 pi over 4. Okay, so that means it's 0, 3 pi over 4, 3 pi over 4 plus 3 pi over 4, okay, is 6 pi over 4, which reduces to 3 pi over 2. All right, and I'm just going to draw a little line here so that you guys know that this goes here. Okay, and then if I do 6 pi over 4 plus another 3 pi over 4, that's going to get us to 9 pi over 4. Okay, so 1, 2, 3 is right here, and that's going to give us 9 pi over 4. Okay. And then if I was to add another 3 pi over 4, that's 12 pi over 4, which reduces to 3 pi. Okay, so I know I did it correctly because I'm just adding fractions the whole time. Okay, and basically just reducing. All right, so you can see it's elongated vertically. It's a horizontal stretch because it goes past the 2 pi, and I flipped it over the x-axis. Okay, and then on the other side, I'm just going to count 1, 2, 3, and I'm just going to make my values the same. Okay. Here, and I'm going to connect the y. 1, 2, here. 1, 2. And then all you guys have to do is show me that like the values are the same. Okay, so as long as you do it to one side, then I'm okay. And then you could just connect the dots and show me on the others. Okay, so there you go. Hopefully that makes sense. Okay, if we have questions, we will definitely go over it on Zoom. Okay, so what I would like you to do is just take a look at this, make sure you understand it, and then I want you to attempt this on NearPod. Okay, so you have examples 3 and 4. Take a look at the amplitude and period. Okay, and make sure you draw in the x values. Okay, for examples 3 and 4. Okay, you can use the text tool on NearPod if you're not sure, because it's probably a little bit easier to write them in, and I try to make the blocks as easy as possible. You could use it on the PDF file and then use it on NearPod. You could always double check your graphs on Desmos as well to make sure that you're doing it correctly. Okay, and that wraps up graphing amplitude and period changes of the original sine and cosine functions.